Nandita ma'am, I have learned so much about the internet from you. However, I still have very little knowledge about how the internet actually functions.
For that, Rajesh, you will need to know about the network layers.
Network layers. What are these, ma'am?
As we all know that before the internet was created, people used to write letters to their friends. It was very simple process. You just write a letter and put the address on the envelope and post it. The letter reached its destination, and once it was read, the reply was similarly written and sent back through the postal department. However, nowadays things have changed and the internet has become the major medium of communication for the people. Today, you simply type the text as an email and press the send button. Email is received, read and replied. You may get immediate response or later. You could also use the internet to chat live and send or receive messages instantly. Sending pictures and real-time video has become common and it is much faster and easier. But do we know what happens when you click on a computer or on your mobile? How does it find the pages on a website you are looking for?
Please explain, Nandita ma'am.
Knowledge of the internet architecture and how it all works is necessary to understand where cyber criminals could take advantage of it and how the internet as a whole could be affected by cyber attacks.
Do you have more information about how the internet is protected from constant attacks, ma'am?
To know more about that factor, it is very important for us to understand the Internet Protocol address. Let me proceed.
Internet Protocol address. Can you give an example, Nandita ma'am?
Sure thing, Rajesh. Let us now take a simple case of you wanting to reach and read a website of a university in USA for your further studies. First thing you would be required to know is the address of the server of this university, which hosts the details about the process of admission in the university. The address of the server works very similarly to a housing colony, with numbers given to each house. Just like an address is given to each house, so each link to any sites have an address in the internet. The difference is that the Internet Protocol or IP addresses are digital. They cannot be like regular house address. An example of a typical IP address is 194.171.2.43. Look at the picture to understand what each part in this IP address represents. The IP address is useful to locate and reach any destination. In our case, we are trying to find the address of a particular university server. Since we already know about Transport Control Protocols (TCP) or Internet Protocol (IP) and know that TCP or IP-enabled joining of various networks and creation of the network of networks. The Internet Protocol (IP) is the core protocol the Internet uses today. The address could be found within this protocol itself. But before we go there, let us understand a few more things.
But ma'am, how can we find the particular address of a certain site?
For that, you need to know the domain name system. Let me explain that to you. Now, it would be very difficult for a human being to remember a big digital number which serves as the IP address of a site.
Yes, that is what I can figure. It would really be very difficult to remember the digital address of so many sites.
On the other hand, a computer which deals with bits and bytes can deal with such numbers. This would be a very big feat for human being. Human being memory can't easily remember a numerical data like the IP address, and hence there is a need to give it a name. Domain name system, which is better known as DNS, was invented in 1983 to solve this problem. The job assigned to DNS was to connect domain name to its corresponding IP address. The DNS is global and decentralized, and the names are not repeated. Do you know how the DNS was structured, Rajesh?
No, ma'am.
You could imagine DNS as resembling a tree, with a root which serves as an orientation point, and branches and sub-branches spreading outward. DNS consists of domains and subdomains. The top-level domains are referred to as TLDs in short. Some of the examples of TLDs in use every day are .com, .org, .in, .us, etc. The entry to this level is controlled by an organization known as Internet Corporation of Assigned Names and Numbers, or shortly called ICANN, ICANN, to ensure a smooth run of the Internet administration and operational tasks. Each TLD is run by a registry which coordinates with other registries to ensure uniqueness of the domain names. Separating domains in this way allows different registries to manage the different TLDs. For example, a .com will be managed by a separate registry than .org. These registries are responsible for keeping the records for their assigned TLD and making infrastructure available to the Internet so users can map each domain name to its corresponding IP address. The DNS use computers, which are known as name servers, to record or map domain names to the corresponding IP addresses using a database of records. TLDs are followed by subdomains and sub-subdomains and so forth, with a maximum limit of 127 levels.
So, Nandita ma'am, that is how the network operates?
Actually, Rajesh, there is more to the network and how it operates. For that, you need to know about the architecture of the network layers.
How does the layers in the network work, Nandita ma'am?
Let me explain. In accordance to the International Standards Organization, or simply referred as the ISO, maintains a uniform for the network. These standards divides the networks into 7 layers, depending on the complexity of the functions each of these layers provides. ISO Open System Interconnection (OSI) model lists these 7 layers. Let's check what these layers are one by one.
So, it's all about layers in the network, ma'am?
These layers are actually tilted up to make a 7-tiered layer. The first is the physical layer. It deals with network design and hardware, such as physical cables, network interface cards, and wireless radios, beside other electronic devices. Encoding of bits in the medium is also decided by this layer. Finally, the transfer of each bit of data is responsibility of this layer. Then comes the data link layer. Encoding and decoding of data packets into bits is done at this layer, and the packets are provided reliable transmission by using the services of the physical layer, which is responsible for transmitting bits over the medium. The next is network layer. Just like a traffic policeman, the basic functions of network layer are routed and control on congestion. It deals with deciding how the packets will be routed from source to destination. The word routing means the route taken or how the transfer will take place. After that is the function of the transport layer. To know how the transport layer works, let us consider the data as the domestic load which has to be transported from one place to another. Like at home, we first need to prepare the bulk of load into small manageable packets. Each packet requires to be marked with the necessary details at its both ends, such as to what is it and where is it headed to. Transport layer provides transfer of data between the end systems or hosts transparently, and it ensures data transfer is completed. In essence, data is broken down and packets are made and ensured that the data arrives free of any errors, and then it is finally correctly reassembled. Now comes the session layer. Just when you log in for a session, this layer primarily deals with the sessions, which includes establishing and maintaining a session. Sometimes a session breaks, but when it is reconnected, the session starts from the same place where it was broken up. After that is the presentation layer. As you might know, that data can be sent in different formats by different sources, which makes it difficult for computers to communicate. Presentation layer encodes the data in a standard network format and the vice versa. This layer is concerned with the syntax and semantics of the information transmitted. The seventh layer is the application layer. The application protocols meant for getting access to the network are part of this layer. There are several such protocols which function in the application layer. For example, commonly used protocol for web browsing is HTTP, and for file transfer it is FTP.
So this is how the internet is protected from intruders, Nandita ma'am?
Yes, Rajesh. However, also need to know about the protocols in the application layer. Let me explain. Well, Rajesh, when we talk about protocols in the network, there are also some other things necessary to keep the network safe.
What are these, ma'am?
The protocols used in the application layer are called Simple Mail Transfer Protocol, which is also shortly called SMTP, used for transferring email. Internet Message Access Protocol, or IMAP, and Post Office Protocol version 3, or POP3 as it is known, play a critical role in the process. They are the most commonly used internet mail protocols for retrieving emails. Both these protocols are supported by all modern email clients and web servers. Quite interestingly, Rajesh, you always got to remember what are the precautions before clicking on a link in the internet.
What precautions, Nandita ma'am?
Once you have typed the website address or clicked a link, your computer queries the DNS system, starting with the root. It will point towards the record for the destination you are looking for. As soon as you reach your specific query, you will be looked up with the assistance of the main destination server. At this point, you will be required to find the way to reach your destination. After you have found the location of the destination site, it needs to know that it is required to send you the data. The real help will come from the network in the form of the browser, which interprets the click of your mouse as a command in Hypertext Transfer Protocol or HTTP, which is nothing but simply defining as to how to ask and deliver content. Application layer handles the HTTP of the destination site and also for your system. The packets are then reassembled and sent to you as the web page you had asked for. Most interesting part of the movement of the packets is that they only have their identity written on their front and back side and their destination marked on it. Take for example how a very cautious mother sends a child to school. She will put an identity tab on her child's uniform. Similarly, network layer plays the role to route or navigate the packets of data moving from your computer to the destination server and back. Internet globally has got a huge number of public or private organizations who have formed nodes called autonomous systems. AS. These nodes identify each of these traveling data packets and direct them within their network if the destination falls within. Else, nodes consult a routing table and pass them on to the node nearest to the destination. Today, billions of users exist on the internet, and there are large numbers of gatekeepers too.
So, ma'am, it is very important for us to behave responsibly while using the internet.
Definitely, Rajesh. As I have already told you, that billions of people are now using the net for different purposes, and some of them may not be operating on it for the right purpose. To go for a recap of what you have learnt so far, just click on any of the buttons on the screen. IP address. The IP address is useful to locate and reach any destination. In our case, we are trying to find the address of a particular university server. Since we already know about Transport Control Protocols, TCP, Internet Protocol, IP, and know that TCP or IP-enabled joining of various networks and creation of the network of networks. Domain Name System, DNS. Domain Name System is better known as DNS, was invented in 1983. The job assigned to DNS was to connect domain name to its corresponding IP address. The DNS is global and decentralized, and the names are not repeated. ISO, Open System Interconnection, OSI model. ISO Open System Interconnection, OSI model lists 7 layers in network protocol. They are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The network layer plays the role to route or navigate the packets of data moving from your computer to the destination server and back.